Number 5. Galápagos. Nearly 5 centuries ago, the Bishop of Panama accidentally drifted to the Galápagos and documented giant-shelled tortoises never seen before. Since then, Galápagos giant tortoises have become symbols of longevity. They can live over a century, many individuals exceeding 150 years, moving so slowly that time itself seems unable to touch them. An international study in 2022 surveyed over 77 reptile and amphibian species. Results showed tortoises have extremely low aging rates. Their hard shells serve as biological armor against aging, reducing injury risk and maintaining internal homeostasis. Unlike warm-blooded humans who must generate their own heat, Galápagos tortoises are cold-blooded. They absorb heat from the sun, their metabolism runs slower, producing fewer reactive oxygen species. Fewer free radicals mean less oxidative stress and extended lifespan. This is a simple yet effective mechanism, a biological key that modern laboratories are actively researching. Lonesome George, the last individual of Chelonoidis abingdonii, died in 2012, but George's DNA opened a new research era. Scientists from Yale and the University of Oviedo discovered numerous gene variants related to DNA repair, immune function, and cancer suppression. Their cells easily trigger apoptosis when encountering errors, preventing cancer from its earliest stages. Number 4. Greenland Shark. Leaving the sunlit lands, we journey to where light never reaches the Arctic ice. Beneath the cold, dark waters, Greenland sharks live like phantoms, silent, heavy, and nearly immortal. These are the longest-lived vertebrates known to science. They grow incredibly slowly, less than half an inch per year, and exceed 20 feet in length. In 2016, one female shark was determined to be around 4 centuries old, born when Charles I reigned England, reaching maturity when George II ascended the throne, still alive when bombs fell during World War II. A single lifetime spanning multiple eras of human history. This extraordinary age was determined through a remarkable method, examining proteins in the islands. These proteins form before the shark is even born and never decompose. Julius Nielsen and his team at the University of Copenhagen measured carbon-14 isotopes, determining ages ranging from 272 to over 500 years. Even at the lowest estimate, Greenland sharks shatter all longevity records. The secret, like Galápagos tortoises, everything revolves around slow living. They swim less than 2 miles per hour, their body temperature entirely dependent on seawater. NOAA submersibles have observed them at depths exceeding 2,600 feet, and they can potentially dive to 7,200 feet. A 2024 study measuring muscle enzyme activity from 23 individuals discovered something extraordinary. Their metabolic activity remains stable regardless of age. No deterioration, no decline, just continuing endlessly. Number 3. Anoxycalyx joubini. In the frigid, desolate waters of Antarctica lives a creature seemingly motionless, yet possessing a lifespan that challenges imagination. The giant glass sponge Anoxycalyx joubini, standing over 6 feet tall and nearly 5 feet wide, they resemble crystal towers rising from the seafloor. Their glass skeleton is constructed from countless silica spicules bonded by silicatine enzymes, creating a framework more durable than human-made fiber optic cables. Over 10 years of observation, many individuals showed virtually no growth, evidence of metabolism slowed to the extreme. This glacial pace allows them to reach lifespans of 15,000 years, with some studies predicting 23,000, even 40,000 years. That's enough to have witnessed the last ice age, to have seen woolly mammoths leave footprints on frozen tundra. The marvel doesn't stop at longevity. Among the glass sponge family is the Venus flower basket, famous for its exquisitely delicate glass skeleton that sparkles like a chandelier. When young, a pair of tiny shrimp enter inside the structure. As they grow, the silica spicules gradually close, transforming the crystal cage into an impenetrable home. The shrimp pair lives their entire lives within the glass frame, dying together without ever separating. This symbiotic relationship has made Euplectella a symbolic wedding gift in Japan, an eternal vow till death do us part. Their silica skeleton not only provides durability but can also conduct light from bioluminescent organisms, turning the entire structure into a dim beacon in the eternal darkness. Further away, in the East China Sea, Monorhaphis chuni possesses silica spicules over 2 meters long, with concentric rings, recording 11,000 years of climate history. They're like giant living climate archives, preserving records of ocean temperature fluctuations across millennia. Number 2. Turritopsis. If tortoises and sharks defeat time by living slowly, then the true journey to immortality begins at the tiniest scale, small enough to fit on your pinky fingertip. Turritopsis dohrnii, a transparent jellyfish, barely a quarter inch, possesses the ultimate trick of reversing its entire life cycle. When exhausted, injured, or facing sudden temperature drops, it contracts into a primitive cyst mass, then redevelops back into a polyp stage, continuing to produce new medusa generations. Not absolute immortality, but evading death from aging by reversing the biological clock, and this process can repeat multiple times. Under the microscope, this isn't magic, but cellular reprogramming technology. Mature cells directly transdifferentiate. A muscle cell can transform into a nerve cell. During the cyst stage, cellular machinery activates numerous DNA repair programs, cleans up damaged proteins, and reorganizes chromatin. The result, not prolonging old age but active rejuvenation. If humans could reset this cleanly, the anti-aging cosmetics industry would go bankrupt. While Turritopsis waits for crisis to hit the reset button, Hydra, a delicate freshwater creature less than an inch long, chooses not to age from the very beginning. Hydra's secret is a continuous river of stem cells flowing along its body. 3 cell groups take turns dividing regenerating tissue daily like a factory that never stops. In laboratory conditions, mortality rate doesn't increase with age. A classic example of negligible senescence. The molecular referee is FOXO, an ancient evolutionary switch that maintains stem cell renewal rhythm, protects against stress, and sustains immunity. When FOXO functions stably, Hydra resembles fresh grass, cut it, and it regrows, worn here, replenished there. Side by side, we see 2 paths to immortality: event-based, regenerating when needed, and foundational, maintaining youth through ceaseless renewal. One reverses the life cycle, the other locks eternal spring. Both strike at aging's core, accumulated damage and loss of cellular identity. Number 1. Arctica islandica. While jellyfish press rewind and Hydra renews daily, Arctica islandica chooses another strategy, living so slowly that aging becomes nearly negligible. Beneath its round shell with dark brown periostracum, this seemingly ordinary clam is an energy conservation machine. Slow respiration, low metabolism, minimizing reactive oxygen species. If aging is a storm, it shelters in a metabolic bunker. Born in the cold waters of the North Atlantic, from Labrador to Iceland and across to Europe, ocean quahogs bury themselves in sandy mud at moderate depths. In warmer southern ranges, they dive deeper to maintain their golden zone of 6 to 16 degrees Celsius. Not spending energy on movement or thermoregulation, they invest in cellular maintenance. Antioxidant enzymes remain stable, especially superoxide dismutase, restraining protein and lipid damage across centuries. The most famous individual is Ming, over 507 years old, born when the Ming dynasty still flourished in China. Age was determined through sclerochronology, reading shell growth rings like tree rings, each line representing one winter survived. Thus, clamshells become handheld climate chronicles, allowing reconstruction of bottom water temperatures and oceanic oscillation rhythms like the AMO or NAO. What makes this species nearly biologically immortal is that mortality risk doesn't increase significantly with age. After the first few decades of growth, the body enters long-term, stable mode, slow metabolism, sustainable maintenance systems, minimal DNA damage. No need for regeneration or life cycle reversal. Just no rushing. But longevity has its price. Late maturity, taking 2 to 4 decades, makes the species vulnerable to overfishing and climate change impacts. In southern ranges, warm water initially promotes growth, but when exceeding the golden zone, shell rings become thin, then discontinuous. Arctica is a mortality journey, isn't magic, but minimalist living technology use little energy, repair meticulously, record consistently. From Ming to countless nameless shells beneath cold sand, each individual is a time capsule. Witnessing that to defeat aging, the secret isn't running faster, but slowing down the right way. After journeying with creatures that defy time, from Galápagos tortoises, Greenland sharks, glass sponges, immortal jellyfish to Iceland clams, the answer becomes clear. Nature has proven immortality isn't just living forever, but knowing how to live slowly, self-repair, or constantly renew oneself. Perhaps humans can't achieve absolute immortality, but we can learn to extend our health span, not to escape death, but to live each day more fully. So, in your opinion, which secret from nature, living slowly, constant regeneration, or life cycle reset, is the closest path to help humans reach the dream of immortality? Share your thoughts in the comments, and if you want to continue exploring nature's miraculous stories, don't forget to hit like, subscribe, and turn on notifications to join us on this journey.